This is section 8.2, area of a surface of a revolution. So we're going to rotate the function over the x-axis or the y-axis and create these bands, and that's what we're going to approximate. And here's the formula for surface area when you're rotating over the x-axis. When you're rotating over the y-axis, it's going to look more like this. And so everything is the same, the formula. The only difference is that it should be 2 pi x instead of 2 pi y. And therefore you're integrating with respect to y instead of x. So when you're rotating about the y-axis, this y becomes an x, and this becomes a dy, and this becomes dx over dy. That's the only difference. So let's look at the first example. They want us to find the exact area of the surface obtained by rotating the curve about the x-axis. So that's key. So that means that our formula, well, first let's just take the derivative since we're going to need to do that. So 5 minus x to the 1/2 power, if you differentiate that, you get 1/2 5 minus x to the negative 1/2 times negative 1. There it is. And then we need to square both sides. So if you square both sides, you're going to get 1/4, and then 5 minus x in the denominator. So that's what we get after we square. So the formula becomes surface area is going to equal to integral from 3 to 5, 2 pi, and once again it is 2 pi y when you're rotating about the x-axis. So 2 pi y square root of 1 plus the derivative squared, which is 1 over 4 5 minus x, all with respect to x. Okay, so now we need to simplify this part here. And also, since we're integrating with respect to x, we don't want any y, so we have to substitute the function into y. So this is going to become 2 pi. Instead of y, you're going to replace that with radical 5 minus x, which is just the function y. And then if you simplify this, that's going to become the square root of, let's see, that's going to be 4 5 minus x over 4 minus 5 minus x plus 1 over 4 5 minus x dx. So what I did is I converted the 1 into this fraction so that I could have a common denominator. Now, when you combine like terms on the top, it's going to become the numerator will become negative 4x plus 21. The denominator is just going to be 2 radical 5 minus x. And as you can see, you'll be able to simplify here. The 2's cancel, the radical 5 minus x cancels. And so you're just left with this integral over here from 3 to 5 of pi. And you're going to have negative 4x plus 21 to the 1/2 power. I'm just rewriting the square root as the 1/2 exponent. And then I can do a u substitution if you'd like. I'm going to go ahead and do a u substitution to integrate, which means du would be negative 4 dx, which means that negative 1/4 du equals dx. So that means that this integral will now become negative pi over 4, 3 to 5. And that's going to be, actually it's not going to be 3 to 5 anymore. The limits are going to change because of the u substitution. It's going to be u to the 1/2. The new lower limit, if you substitute 3 into x, becomes 9. And the upper limit, if you substitute 5 into x, becomes 1. All right, so now this becomes negative pi over 4. That becomes 2/3 u to the 3/2, 1 to 9. And that should give us, let's see, we should get, well, this 2 simplifies with that, and that's going to be negative pi over 6. U to the 3/2, 9 to 1. And that's just going to be negative pi over 6 plus pi over 6 times 27, which turns out to be 26 over 6, which turns out to be 13 pi over 3, which is our final answer. So that is the surface area. All right, let's look at the next example. The next example gives us the function of x in terms of y. So we can leave it that way. And let's take the derivative. That's just going to be 4y. Now, when you square that derivative, you're going to get 16y squared. All right, so now the surface area is going to be from 1 to 2. We're going to integrate with respect to y. So that's going to be 2 pi y square root of 1 plus the derivative squared. All right, and this is with respect to y now. Okay, and let's see, what can we do to simplify? Well, for this, you don't really need to simplify. You can't. You can just do a u substitution to integrate. So u will be 1 plus 16y squared. Du will be 32y dy. Dividing out the 32 gives us 1 over 32 du equals y dy. All right, now we can substitute out the y dy and replace it with 1 over 32 du. So, but since there's a 2 here, that's going to cancel out, and that's going to become 16. So let's rewrite this as surface area is now 1 to 2. It's going to be pi over 16. All right, and now we have u to the 1/2 du. So this becomes, the limits are actually going to change again because of the u substitution. So if you substitute 1 into y, you're going to get 17. And if you plug in 2 into y, you're going to get 65. All right, so that's going to be pi 16ths times 2/3 u to the 3/2. And we're going from 17 to 65. Once again, you can simplify 2 goes into 16 8 times. So that's going to be 20 pi over 24. And then if you substitute the 65 into u, you're going to get 65 to the 3/2 minus 17 to the 3/2, which is the final answer. If you want to rewrite this in terms of radicals, you can. That's just taking it an extra step. That would be pi over 24. That would be 65 radical 65 minus 17 radical 17. That's an optional step. You don't have to go that far if you don't want to. You could have left your answer in this form. All right, let's take a look at the final example. Okay, so for this one, so it looks like this time we're going to rotate about the y-axis. So we're going to integrate with respect to y this time. So our integral, well, let's solve for x first. So solving for x is going to be, x is going to equal to 1 minus y to the 2/3. And then that still, we have to raise both sides to the 3/2. So now we're going to have x is equal to 1 minus y to the 2/3 to the 3/2 power. All right, now if we differentiate, we're going to get x prime is equal to 3/2, 1 minus y to the 2/3 to the 1/2. Chain rule says times negative 2/3 y to the negative 1/3, because I differentiated the inner function, and that's going to give us this. Well, it looks like there's some simplifications that can happen. 2, 2, 3, 3. So now we can rewrite this as negative y to the negative 1/3, 1 minus y to the 2/3 to the 1/2. So now we need to square this derivative. So when you square that, when you square a negative, it becomes positive. And when you square this, that's just going to be y to the negative 2/3. And when you square this, that just becomes 1 minus y to the 2/3. If you distribute, you're going to get y to the negative 2/3 minus 1. Okay, so now we can plug it into our formula, the surface area formula, which says that we're going to have the integral from 0 to 1. Those are our limits for y. And it's going to be 2 pi x this time, square root of 1 plus the derivative squared, which we just found to be y to the negative 2/3 minus 1 with respect to y this time. We got the simplification there. All right, so now if we simplify this, we should come up with that's going to be, so the square root of this is just going to be y to the negative 1/3. All right, that's what happens when you take the square root, or this to the 1/2 power. The 2's cancel and you're left with negative 1/3. All right, but now you have to replace the x with the function so that we can write this in terms of y. So if you do all that, you're going to get 0 to 1, 2 pi, 1 minus y to the 2/3 to the 3/2, y to the negative 1/3 with respect to y. All right, in this case, we can now do a u substitution. So u is going to be 1 minus y to the 2/3. du is going to be negative 2/3 y to the negative 1/3 dy. And this is what we need to substitute out. So that works out nicely. We just have to move the negative 2/3 to the other side. So that's negative 3/2 du equals y to the negative 1/3 dy. Now we can substitute this out. So the integral now becomes 2 pi u to the 3/2. And actually, because there's a negative 3/2, so that's going to cancel out the 2's. You're going to have a negative 3 pi in the front. So let's write the negative 3 pi in the front. Negative 3 pi in the front. Our limits change. Now we have u to the 3/2 with respect to u. And now let's look at what happens to the limits. So if you substitute 0 in for y, you're going to get 1 for your lower limit. And if you substitute 1 in for y, you're going to get 0 for your upper limit. Okay, and so there we go. Now, taking the antiderivative is going to be 5 over 2. So that's u to the 5 over 2. That's going to become negative 6 pi. And we're going from 1 to 0. Substituting in 0 just gives us 0. So we're going to have 0 minus negative 6 pi, which is positive 6 pi. And that is our final answer.